Hello and welcome back to the development of the Feersum scheming compiler. So in today's stream I'm going to continue looking at the implementation of macros. In the last stream I started, I was continuing looking at the implementation of macro patterns and implemented parsing of macro patterns. So the compiler now has a pretty thorough support for the macro patterns that the R7RS scheme specification specifies. And we can parse them using this parse pattern that was written in the last stream, which is a recursive function that looks at the pattern nodes and turns the syntax tree into a macro pattern. In today's stream, I want to have a look at the other side of a syntax rule, which is called a transformer. So in scheme, let's go write some scheme first. So in scheme, we can have something like this. Define syntax. We call it our macro test. Then we say syntax rules. And then we say if you say test and then any number of A's, then we transform that into how about display a begin and then display a repeated. I'm not in Emacs. Something like that. So this defines a macro and binds it to test, and the body of the macro is this set of syntax rules. The syntax rules don't have any literal identifiers, and actually it should be test, I think. So that means that if you say test and then any number of any kind of form, this macro pattern will match it. So that actually this needs to be a pair. So it's like a list of transformers, or a list of syntax rules which are made up of, on the left hand side, the pattern, and that's what we support parsing already, and then on the right hand side there's what's called the transformer, which is how we turn a match from the pattern into some new syntax. So if we wrote something like test 1 2, then that would be transformed into begin display 1 display 2, and so we would hopefully see that evaluate to something like 1 2, because we've not got any new lines or anything like that in there. So to do the whole of this, we need to be able to recognize macros, have macros in environments and all the rest of that kind of thing. But in today's stream, I just want to look at the right hand side, the transformers, and then taking some kind of fabricated match and turning it into a transformer, into some new syntax with a transformer. So I'm going to start by, we've got this parse pattern, we've got in the macros, we've got the macro match method is the main entry point. So I think I'm going to have another as well. We'll have macro expand, which will take the output of the macro Yeah. So it'll take the list of macro bindings, which is what gets produced by macro match, and it will turn it into a syntax tree. So it's going to need, you're going to need to give it some syntax to expand with. So this would be, once you've got a match, try and work out which way around we want this to be. So maybe we'll give it some syntax and some bindings so that we can compose this together later. And no, this should be a transformer. And we will match over the transformer. And this is where we need to start defining what a macro transformer is. So transformer. I'm going to say it could be, it could either be a variable or a quoted thing, I think. So quoted would be if we've got something literal that we want the macro to just paste in, and the variable is where we're wanting to look something up from our set of bindings. So I'm wondering if it should be called substitution, which is just going to be the name of the variable to substitute. And there's also going to be things like forms. I'm trying not to preempt what how we're going to structure this. So let's leave it like that. So this is the macro transformers specify how to convert a match into new syntax. They are effectively for the syntax with holes to be in by matches. So I guess the simplest case is if there is a quoted form, we should return the quoted form regardless of what the bindings are. And I think this is going to want to return a result again, so I'll do OK of the quoted form. And if it is a variable, then we want to do list.find list.tryfind in the bindings list what is b dot, well, what's in a binding? We don't really have enough type information here. Macro binding. This is just a pair of string and syntax node. So I can just use a pattern in here, can't I? So we find the one where the ID equals the variable name. Macro pattern. What did I call it? Just subst. So that's going to produce an option, and then we want to do, is there a way of converting a result? I'm going to turn an option into a result. Result dot get to don't, or else we don't want to give it a default value. We just want to say if we succeeded. So if we did manage to find a binding, we want to return an, unless macro expand just returns an option. That's not really. Let's do a match. I'm pretty certain in Rust there's a way to turn an option into a result. I think like results you can do like result.ok or something that returns an option of the OK value. To go the other direction. Some match. So this is going to be some ID and syntax. And we'll return OK syntax. And none, we will return error. What is the error type going to be? Guess we can just return the message here and then have whoever calls macro expand turn it into some type of syntax error if needed. So error is going to be reference to or V, isn't it? And this needs to be result.error because we've aliased it by accident in other places. So let's make that result.ok just for consistency, and that indeed wants to just be a single equals. Alright, that looks like it might even work for those two cases. Expand any bindings, expand macro transformer with the given bindings. Okay, let's go write some tests. Macro expand tests. With maybe some more letters in there. Let's call this simple macro expand, and we'll make it a fact. So this is just going to use like a hard-coded syntax template, and it's going to use a hard-coded set of bindings. Let's expanded equals macro expand. We need to give it something to expand, so we'll say macro templates. What, have we not made that public? Maybe not. No, macro transformer. So we can say, how about quoted, and then we can make literal or number. Numbers are easy to make. So if we have something that should expand into the quoted 123 and no bindings, we should be able to assert assert equal and that should be okay. And these need to be floating numbers. And that's not okay. Good. Maybe even that test will work. Should point out that I've now switched to .NET 5, so now we have a stable build of .NET 5 rather than the pre-release that I was using earlier. So maybe it'll be a bit less crashy. We'll find out. I'm hoping that VS Code will be a little bit happier with the whole thing. And we've got 2 failing tests, but I think that is the example macro thing that I wrote rather than anything particular. We can solve that by using, what is it, hash, then hash, and then that, which is it quotes a form like that, maybe. We'll still get 1 failure because we don't have any syntax passed for it. But yeah, snapshot doesn't exist. We get unexpected character. Syntax. What is the syntax for quoting a datum? No, commenting. It is hash and then the comment symbol. That kind of makes sense. I was getting it confused with fuzzy quoting and stuff like that. Hopefully that works. I could just get rid of that macro example. Let's just do that. Not really bringing anything. Restart. Maybe? Failed to terminate and restart the task. Well, it's because it had already finished, isn't it? So we have support for expanding macros, which is nice. It would be even better if we can expand something that's got. That is not how expanded is spelled. Is it? macro expand. How about we try something? Transformer substitution, and the substitution should be test. And we should have one binding that contains test bound to we have number. What else do we have that's easily created? What do we have in our syntax factory? Constant. We can do a constant bool or something, or yeah, might as well. So hopefully that should also work. And it should be constant boolean true. Maybe that works. The other test I suppose we want to do is to try and expand something like that we don't have any bindings for. It would be really, should we do assert true expanded dot is error? What type is expanded? Yeah, it's a result. Result dot bind map error. I thought there was a result dot is error. Nope. Let's go make one. We have result ex for all these kind of things. So we don't want unwrap, but we could do let is okay. It's okay. And true. Return false. Oh. And we'll do the same thing for error. We should just make that error. I mean, we could actually make that like not is okay. Is that, or is it going to be is okay not? Yeah, like that. What do you set it up? Okay. That's because it's fair enough. Why don't I have to pass that? Result ex dot is error. Maybe. Type annotation may be needed. Let's do it the less fancy way. I could probably have got to by just doing a whole lot of control Zing as well. Here we are. Does that look like it's going to compile? Maybe. Unique overload for the method true. Because it's expecting Boolean. Doesn't know if that's no. Let's just run it. It could be an out-of-date compiler. Open utils. That's looking a lot better. So we have support for expanding macros with simple transformers. Let's start trying to parse transformers. So where's parse pattern? Let's do a parse transformer. Parse transformer, and this takes, oh, that took a literals and a syntax. This just needs to I was wondering whether or not we need to know what the variables are that have been found when we parsed the original syntax. We'll see. It's going to start off as a function, and it's going to say, "Oh no, we want to do it as syntax," and then because our syntax node, what we really want to match on is the kind. And then, so if it is a form, we will want to recurse in some way. And build up some kind of nested template. If it is anything else, if it's an ident, we want to do something special. Which I think for the time being is going to be just turn it into a macro variable, which we can do by just saying okay macro transformer dot variable or subst id, and then that needs some brackets, and then anything else we can just return it as a quoted form of the original. Macro transformer dot quoted. This doesn't quite handle all of the cases, because I haven't handled repetitions yet in our substitutions, but pass a macro transformer specification from a syntax tree. And then we can start writing slightly more advanced tests. What would you want to say? I think what we'd like to be able to say is something like give it a pattern. So the pattern would be like if the pattern is A and the transformer is quote A. No, that's going to be more difficult. The transformer is just A, and we try and match it against the form 1. Then we expect the result to be 1. Maybe. We want to write a test like that. So let's macro expand tests. It's going to be pattern transformer pattern transformer invocation or reference, or maybe something like that. Oh dear, VS Code's having a bad time. This is because I've spent too long with one of these backtick identifiers around. Time to kill it. Right. Hopefully that's got us out of the hole. No, it hasn't. No, it has. It's worked. Right. And something at the end. Go again. This is exciting content. I wonder if it's because this doesn't match up. Maybe an Emacs thing again. No, close it. So let's try and open that test again, but this time using a real editor. So invocation, and the last one is expected. And what we effectively want to do is pass the pattern which, oh, we're doing it up here. Pattern try match. Try match takes a literals and a pattern and a haystack, and it does pass pattern, and then so we can do try match to get the match, and then we can do try expand maybe. That bindings equals try match pattern with the invocation. Then we'll do equals macro expand. Hey Raw, what's up? Macro expand. Don't know how long it is since you sent that chat message because you've been hidden behind me frantically trying to restart the .NET build server. Get my editor to just try to do what it was designed to do, which is edit code. Macro expand. We want to expand the... Well, we need to pass the transformer, don't we? I guess try expand might be a good idea. Try expand the transformer. That's a while ago when the macro expand fact passed. So try expand the transformer with the bindings. And then I think we want to do like assert.equal expected and then like pretty, I'm just going to call this PP. So effectively we want a try expand which takes transformer and some bindings. And this is going to return none for the time being. And pretty print, which will take some syntax. And is going to return the empty string for the time being. So I think so try expand once in this case, that's gonna, what we really want here is option unwrap on the bindings, because that's, which we can just do here. That'll throw if we don't end up matching. And try expand. Again, we'll throw if we fail to expand. Let's try and open up code again. Strap in and wait for everything to go green. If I want to do some JavaScript code during my C# build, and I've got Nuke to do that using reflection and string building, do you know if there's a fancier tool for the code generation part? So are you using JavaScript to generate C# during a .NET build? What are you upset about? Bindings. Try match. Locked up again. What is it so upset about? And what is triggering the bad behavior here? You want to split, you want to spit out a JavaScript client based on C# code. I think one option would be to use Blazor and not write the JavaScript yourself. If you are basically using reflection, walking through some C# and then generating, you're effectively transforming it into something else. Yeah, I don't know. Don't know what the best solution is for that. But it does sound like the problem that Blazor was designed to solve. I'm going in the other direction. Generating C#, you'd use .NET source generators. It's a bit like compiler plugins that produce C#. I imagine you're now going to tell me that Blazor is not an option. String try match. Try match takes a haystack. Pattern literal. Literals. We haven't got any literals, so we just want that to be empty. That should hopefully type check now. Let's run this test. And I expect it to fail for a variety of reasons. Is source generators .NET 5? Feels like it's been around for a while, but work on .NET 5 has been around for a while, so I don't know. Go have an investigate. April 2020. Which does feel like a long time ago, but if you look on a calendar, isn't really that far away. Did you run the tests? Maybe? Output. Oh, it still says fetching tasks. Await activating extensions. Kind of feels like something is still not working properly. Just try .NET test from the command line. Oh, it's locked up again. Right, I'm doing it with Emacs. Let's go set up a compile. So we want to do .NET test. No. What? .NET command not found. Madness. I think this is because it's an old Emacs session and it may have been. Emacs has been open for weeks and may well predate the installation of .NET 5. I don't know however many times this has been reopened. I don't necessarily expect it to start working. But it's loaded the project. Can I run the test task? It's building it. That's positive. I think that's worked. Yep, it's run the tests. Why did that pass? Expected 1. Why is that? No tests found. You just haven't found any? Or it hasn't looked? Is that stopped because the editor's locked up, or is it stopped because it's loaded something? Right, this is looking better. So let's go and edit the test. Macro tests. So in our macro test, I didn't have a look at whether or not that actually passed. Go have a look. Compilation. Yeah, it says that's all worked. Can I do like this? Must be not being run or something. Expanded. Oh, that was stupid. Just hadn't actually marked it as being a theory. Good. So try expand. What's try expand going to do? It's going to say let transformer, or I won't. Yeah, let transformer equal match read single node transformer. So we need to pass the syntax first and then run that through pass transformer, which will then return us a result, which can either be okay, and we just return it. Let's call this T, because T should be then, which I think this is turning into unwrap. So we'll say read a single node, parse a transformer, and then unwrap it. That's the transformer done. Then we just want to do match macro expand transformer bindings. If it is okay, we'll return it. And if it's an error, we will fail with it. Let's try running that again. Let's reset the text size. Using string builder isn't necessarily bad. It's definitely the best way to build strings. If you're trying to build source code for something, it might be better to try and build up syntax in some kind of structured way and then print it out. Have some kind of, so you can look at some kind of structured representation of the syntax. And depending, I haven't looked into it, but there's what's called round trippable syntax. So you can pass syntax into something that can then be serialized back to the same on disk representation. If there's a JavaScript parser or something, C# that does that, it might be possible for you to build a syntax tree for that and then serialize that out and have it like pretty print things properly for you. Value of constructor transformer is not defined. Where? Here. Because not spelled it properly. Expected to have type AST node string, but here it has AST node kind. Don't know what's gone wrong there. This expression was expected to have type AST node, result AST node string, but here it has type AST node kind. That's an AST node. That's an AST node. Why does it think that is an AST node kind? What's by expand being used as? Just not know. Oh, I know what it is. It's because we want this to be sum. Because we're optionally returning syntax node. Thanks, Raw. I'll see you whenever you're next streaming. Expected to... Oh, I see. It's the result thing again. Gonna be a big change to rename result error, sorry, from the AST node kind, but it is really awkward that it aliases. Right, and now we are getting a nice error. So the expected was 1, but the actual was empty. So we want to handle all of the types of syntax node. So what we're going to do is match syntax.kind, and then we'll say if we've got well, right now we can say if we've got a constant, then we'll just return toString on the inner thing. Otherwise, we will return. We'll throw. This might make the unit test pass, which would be glorious. Nope. Fail with is not defined because I can't spell. I need to try and turn on fly check. Yes. Actually, I think I have it turned on. I think if I make an error, does it turn? I just don't get the inline fly check. I don't get these squigglies. So if I make something like this, yeah, I get a little thing here which is telling me that there's. It's saying diagnostics. Yeah, then it's saying errors. Need to find out how to turn on inline fly check for that. But why did you fail? Through a system exception. Could not. So it's number 1.0. We could let's do pretty print constant, I guess. And a toString. this is going to be if B, then T, false. And then we'll just say unsupported constant for the time being. Ooh, yeah. I think we can. Include that. And then we say we just do pp const c. So I think this is going to end up with 1.0, but if we do this, we should end up with what we want. Constant. System reflection metadata constant. That's not what that is not what we want. What is the type here? That is a syntax constant. Is looking more likely. Just notice that after having claimed earlier that we're using .NET 5, that is still building a Netcore app 3.1 executable. I think I'm just using the .NET 5 SDK to build .NET Core 3.1 things. Okay, so that test now passes. So we can now write some tests for some macros. So if we have a pattern that matches anything and we replace it with some constant and we match it against something, we get whatever. So let's do, how about a pattern that matches any number of A's. Match it against some things. That would I would expect that one, because we're replacing it with a constant value. I expect that one to also work. Do parse syntax, parse transformers from syntax. We don't support repeated transformers yet. I'm running out of steam, so I'm going to give up and come back to macro patterns another day, I think. What's gone wrong here? Expected. So not gone quite as well as would have been liked. Unwrap on a non. Transformer 1, 2, 3. Invocation, blah. Expected. Called unwrap and non. Line 42. Line 176. How about I actually go to the right place? So it's not matching. Not match. pattern. Try and match the pattern against the invocation. I'm just going to try and match a dot dot dot. Let's go add some logging. Hopefully we'll be able to work out from that why we can't match this pattern. Could well be that we found a bug in the pattern parsing. It's the one that has failed. Parsed pattern. Form variable a dot dot dot. That looks like the right pattern. Why does it not match? Let's just make sure it is that, and it's not that we are doing a bad job with the transformer and that we don't support numbers or something. Why am I not getting line numbers? Anyway, 179. This is 178. This is where it is throwing it. It must be that option unwrap. It means that try match must be failing. We know that invocation is the right pattern. I wonder if we should do some more logging. Hopefully with some new lines in place, it will be a little bit easier. So interesting. So we've got a form. there a printf that does new lines? N printf. No. Maybe. Just put new lines on it. Yeah, maybe. Let's see if that's a bit more readable. So, where the pattern is a variable a dot dot dot. It was there all along. We've been bitten by this before. It's not a bug, other than the fact that it's a ridiculous feature of the language. Good. This, I think, is now going to work. Let's get rid of that logging then. I'm using the word logging very very loosely there. Just a bit of printf debugging in your unit tests. Well, I'm happy with that. So, what have we done today? In the macros, we have added this macro transformer, which we've started to flesh out the things that we can expand macros into, which at the moment are single quotes or substitutions, and we'll have to have some kind of form support in there as well. We've added a macro expand method, which is responsible for taking a parsed transformer and a list of bindings and turning it into a result with a syntax tree inside it. And we've added parse transformer, which is responsible for taking a syntax node and turning it into a macro transformer. The idea being that we can then use parse transformer and the other parse method, parse pattern, to then parse the whole syntax rule when we actually come to implement proper syntax rules. Then the other thing that's really missing from macros is the ability to store these macros in our environment when we're binding, so that when someone references a macro, we can recognize that as being, like if someone says test and then 1, 2, 3, we want to be able to recognize that test is actually a macro here and not a reference to a variable location, and expand the macro instead. So we'll need some support for probably a storage type for macro, and then there's a whole load of stuff to do with macro hygiene and making sure that you bind the right parts of the macro in the right place. But anyway, this I think pretty much does it. So thank you for watching, and I will see you next time when hopefully we'll be able to continue the work on macro expansion and actually support more complex macros that I've nested in parts where only some parts of them are substitutions, and we can have a look at actually properly supporting defined syntax and syntax rules for expanding user-defined macros. So thanks for watching, and I'll see you next time.